Okay, let's take a look at another problem. Caitlin received $5,400 in cash for wedding gifts from her rich relatives. Ooh, I wish I had them. She and her new husband want to invest 40% in an account earning 2.1% interest compounded continuously. The remaining 60% will go in a money market account earning 2.75% interest compounded quarterly. How much money will each account have at the end of 10 years? Caitlin is hoping to have enough money to make a $10,000 down payment on a house at the end of the 10 years. Will she have enough money? And then find the APY for each account. And I put a note here, this is important, when you're finding APY, you will use either simple, general, or continuous compounding formulas. So if your scenario that you're talking about is an annuity or an installment loan, then you will use the general compounding formula. If you have any other situation, if it's talking about simple, you would use this simple formula for the APY. If it's talking about general, as this one is, compounded quarterly, that will use general compounding. And if it says compounded continuously, then you would use the continuous compounding formula. But a big note to you, if you need to find the APY and the formula that you're using for the problem is the installment loan formula, for example, you don't use the installment loan formula to find the APY, you use the general compounding formula. The same thing if your problem needs annuities formula, you will use the general compounding formula to find the APY. Okay, so let's take a look at this problem. I see that we have two accounts that we're talking about. One is a money market. Find where my pen went. Okay, money market. And we have just an account that's compounded continuously, so I'll say continuously. And good thing we didn't assume everything was going to be general compounding or continuously, because we have one of each on this one. So the money market is compounded quarterly, and I need to know how much money we're depositing into each account. So let's check it out. 40% will go into an account getting continuous compounding. So this will be 40%, so 0.4 times the $5,400. And that leaves 60% for the money market account, but still $5,400. So we'll calculate those both quickly. $5,400 times 0.4, that'll give me 40%. And that's going to be $2,160. Okay, move that one so I don't get messed up. Okay, and then I can just change the sign on that and add it to 5,400, and I get 3,240. 3,240. Or I can take the 0.6 times 5,400 and get the 3,240 as well. So either way is going to work. So there's the two deposit amounts. For the first one, the compounded continuously, I have a 2.1% interest, so my rate is 0.021. And my time, remember we just have a few variables for compound continuously. The time is going to be 10 years. So have that up here. For the money market, the rate is going to be, let's look and see, 2.75. So 0.0275. Fix that up. 0.0275. And what else do we know? Compounded quarterly, so that means my N equals 4. And I have the principal amount I need the T, which is still going to be 10. So for both accounts, we have 10 years. All right, so for the money market, I need the compound interest formula. So F equals P times the quantity, 1 plus R over N raised to the NT power. And then I want to fill in all the values I've got. So I have F equals, it's going to be 3240 for the money market times 1 plus R is 0.0275. N is 4 because it's quarterly, and then 4 again times the 10 for the years. So I should be able to calculate all this. Let's see how it looks on this calculator. So I start with 0.0275 divided by 4, and that is going to give me that first fraction inside the parentheses there. So I have this little piece right here, 0.006875. Add the 1 to it, so plus 1 equals, now I have this whole part in parentheses, raised to the, I said you should always do that up front, and I didn't because it was an easy one, 4 times 10, so 40, so that's what I'm going to be raising that quantity to. So to the, make sure I have that 1 on there, to the 40th. It takes a minute for this calculator to get it. And I have 1.31529, and it goes on. Next thing, last thing is to multiply by the 3240. And there is my F for this account. My F comes to money 4261. I think that decimal is right there. Yeah, right before the 5. 0.547, so 0.55. So that'll be the amount for the money market. And then for the other account, we know it is continuous, so I can just write that down, and that formula is F equals P times E to the RT power. So P for this one is the 2160, so I have F equals 2160 times E. My R is 0.021 times 10. That's in my exponent. I want to go ahead and do that first. Remember, if you multiply by 10, you just move your decimal one place to the right. So I expect it to be 0.21, and I want to just double check. 0.021 times 10, and there it is, 0.21 for my exponent. So I can go ahead and cross that off and put 0.21, and then I need to take e to that power. So I'm glad I have it sitting there on my calculator, because this calculator wants you to have the number sitting there for the exponent before you push the e to the x button. So I'll do second e to the x, and it'll give me a value for that. Last thing that I need to do is right here, I've calculated e to the 0.21. Now I need to multiply by 2160. So times 2160. And that leaves me with an F of money, $, and I get 2664.744, so 74. And so $2,664.74 from this other account, the continuous account. So there's the two accounts for 10 years. How much money will each account have at the end of 10 years? So this is part A right here. This is the money market. And so I'll just put a little note with my answer. And then this one is in the continuous account. So please notice I am rereading my questions to make sure that I've answered exactly what they're asking, because oftentimes we get caught up in the question and we forget what we were really trying to find. So I'm modeling for you, going back and rereading, and then being sure to state the answer. Make sure that you're showing at least the problem, the formula that you're going to use, and then with your values filled in, and then you can calculate on your calculator and put your final result. Make sure you label things with the dollar signs. They go in front of the dollar values, not at the end. And make sure you specify which account you're talking about. Okay, so part B, Caitlin's hoping to have enough money to make a $10,000 down payment on a house at the end of the 10 years. Will she have enough money? So I know how much she's going to have in each account. I just need to add them together and see. So 4,261.55 plus 2,664.74 equals, and I can see she's not going to have enough money. So for part B, I would say Caitlin will be about $3,000 short. Of her goal. Okay, last part, C, find the APY for each account. And we talked about which formulas to use, and on this one it's pretty straightforward because it's the same formulas that we use to calculate the interest, but let's check on it. So for the money market account, that had 0.0275% for the R. And remember, we always use P equals 1 and T equals 1. And so the only other thing we need is the N for this one. And we'll use the same N that we used before, which was a 4. And then we're going to plug that in. Then for the continuous, we will need to use P equals 1, of course. And we'll need to use the R equals 0.021, and T is 1. Okay, I'm going to skip down because I ran out of page right there. So remember, we'll use the F equals P times 1 plus R over N raised to the NT power to find our F, which we need for this APY calculations using these values that I wrote up above. So we'll have F equals 1 for the P times the quantity 1 plus my R is 0.0275, my N is 4, and raised to the 4 times 1 for my T. So remember, 1 for the P, 1 for the T, and then the other values from your problem. And using one of those three formulas, this one's a compound interest problem originally, so I'll use the compound interest formula to calculate the APYs. So next thing I do is that division. So I have 0.0275 divided by 4 plus that 1 inside the parentheses, and then raised to the, where's my to the, there it is, to the 4th power. And that gives me an F because I don't have to multiply by anything because there's a 1 out front. So it'll be F equals 1.02778. And I need to go at least 6 spaces. So I have, the next one would be a 4. The following digit's an 8, so I have to bump it up to a 5. So 1, 2, 3, 4, 5, 6 digits is what I need for APY. Because the next thing I do, remember, is F minus 1 and then multiply by 100. And that gives me the actual APY percent. So when I do that, I'll just subtract off this one right here, and then I'll move my decimal 1, 2 places. So it's going to be 2.7785%. And that is the APY for the compounded money market formula or account. I'm sorry. So we have, for this is for the money market. And let's figure out for the other account that had the continuous compounding. The formula here for continuous compounding is still F equals P times E raised to the RT. And remember to plug in those values we just wrote out. So P is going to be a 1 times E to the R, which is 0.021, and T, which is just a 1. Times e to the 0.021 times 1 for the t. Okay, so we can simplify a little bit. That's going to be f equals e to the 0.021. Let's try that out. 0.021 and e to the, and that is my f value right there. So I have 1.021222, 1, 2, 3, 4, 5, 6. Double check up here. 1, 2, 3, 4, 5, 6. Yes, there are all 2's there. Subtract off the 1, remember, and move your decimal 2 places to the right. So we end up with, for the continuous account, we have an APY of 2.1222%, and we need to put APY at the end. Double check that we got everything for that problem. Find the APY for each account. Well, we sure did do that. So there's our 2 APYs, the 2.7785% and the 2.1222%. And so it looks like if we were trying to compare which is the better account, it's definitely going to be that money market account.